I suppose you know how long is 1 second, and I suppose you know, maybe you don't know how long is 1 microsecond, because 1 microsecond is 1 millionth part in 1 second. So let's say that you do want to capture that event, that 1 microsecond event. As you see here is 1 microsecond, and the frequency is 1 second. So every second I send a pulse, and that pulse has duration of 1 microsecond. Once we get here, we see the 1 microsecond kind of show here. It's difficult to see, but it is there. And then that trigger a pulse that has already 5, almost 6 milliseconds. That 6 milliseconds is easy to see with a microcontroller or even with a laptop, with a computer. So that's what you want. Now I'm going to increase the microsecond event, because let's say that it happened to be 1 microsecond, but later you want it to be more than that. So I'm going to increase this microsecond here, and you can see here is beginning to increase, and the output remain the same. I will continue increasing. Now we have 100 microseconds. We got 100 microseconds, and the output remained the same, because that's you want it to be able to capture that event. I could see that it's beginning to show the width of the pulse. Now it's 200. You can see that the pulse is increasing, the event, the duration of the pulse continue increasing, but your output is continue the same, because you really wanted to capture that length. At least you know the minimum length is going to be that. Now they both equal. Now I have 6 millisecond event, and the output continues being 6 milliseconds. From here on, then, because you already saturated, not saturated, but you already reached that, both of them will increase continually to be the same. They always increase to be the same. As you see here, both of them continue to be the same. This is accomplished by using a 555, and you just trigger that in fixed duration by this resistor and that capacitor. I'm putting a transistor here so I could get an isolation, just to get a sinking output. And the input is, I put a divider here because the output could be about 5 volts, 8 volts, 10 volts. So I just get half of that trigger. And the circuit is this one over here that I just prototyped. So once I test it, I will make an official PCB. Thank you. Now we are making or milling the PCB. For that we have this program, Western CNC, and here is the positioning of the point while milling the PCB. It shows the device ready. It shows the different command that we have, and I've reduced the speed to 50%, 55%. The G code is right here as progressing, and here is a visualization where the milling is happening. The green dot show where is going right now. Now look, going to the machine. You can see the PCB formation or milling or tracing going on. Once it's finished, it will be ready for placing the component. And it's nice because it's a homemade PCB, so I could prototype here, and once I'm sure about, I could send it out. Thank you. This instrument, this is final test. This instrument could generate a pulse. As you see, it's a pulse figure here. And the frequency of the pulse, it could be adjusted right here. And the pulse width could be adjusted over here. So if I select, in this case, I wanted to keep a 1 millisecond pulse. And the frequency is how many times happen per second. It will be right here. The signal comes through this cable and enter this unit here from the last design. That was the last design that we did. Now it's a final prototype, or final board actually. Then the signal come here and goes through this processes here and came up through the USB port. The USB instrument takes 5 volts from through the USB. And next we're going to see what happened in the computer. So here we could see that there are 3 composite USB unit. I'm going to unplug the unit. There I unplug. And you see now that we only have 2 composite unit. I'm going to plug again. And now we have the instrument. So one of these composite units is our unit. Now I have a notepad here where I wanted to visualize the pulse. Once the pulse happens here, an equal sign, it will come here. I'm going to enable, and you can see now that the pulse generated by the generator is being progressively here. I could slow down. I could slow down the frequency to the point that almost it's very slow. Or I could speed up the precision just by increasing the frequency of the pulse. And that's it.